For more than 50 years, the trend has been almost impossibly consistent. The first freeze of the season in city after city across the United States has been arriving later and later on the calendar, decade after decade, as the planet has warmed. That trend is so well documented that climate researchers can point to the exact number of days it's shifted in nearly every major American city. And yet, heading into fall 2026, a completely different signal is building in the atmosphere, one that could push the first hard freeze in parts of the country earlier than it's arrived in years, cutting directly against a 50-year pattern that most people have simply come to expect. That contradiction is the entire story here. By the end of this video, you'll understand exactly why the long-term trend points toward later freezes almost everywhere, why this particular year is shaping up differently for a specific stretch of the country, and the exact mechanism in the upper atmosphere that could be responsible for delivering an unusually early blast of winter, even as the broader climate trend keeps pushing in the opposite direction. Let's start with the baseline, because you can't understand why this year might be different without understanding what's been happening for decades. A recent analysis from Climate Central, a nonprofit climate research group, examined first freeze data going back to 1970 across 204 American cities, using National Oceanic and Atmospheric Administration weather station records. Their definition of first freeze is specific and consistent. The first date from August 1st onward, when a location's low temperature drops to 32 degrees Fahrenheit or below. The results were striking in how one-sided they were. Compared to 1970, first freeze is now arriving later in nearly 90% of the cities analyzed, an average delay of 12 days across the full data set. Some cities have seen genuinely dramatic shifts. Reno, Nevada now sees its first freeze arrive a full 41 days later than it did in 1970. Bend, Oregon has shifted 38 days later. Santa Maria, California has moved 35 days later. That's not a subtle trend. That's more than a month of additional freeze-free growing season added onto cities across the interior West in the span of about half a century. But here's the detail that matters most for this story. That trend isn't universal, and it isn't uniform. A smaller handful of cities in the Climate Central analysis are actually trending in the opposite direction, seeing their first freeze arrive earlier than it did in 1970. Dothan, Alabama, has shifted 16 days earlier. Waco, Texas, has moved 11 days earlier. Charlotte, North Carolina, has shifted 10 days earlier. Those cities are the exception within the broader data set, not the rule. But their existence proves an important point. The long-term warming trend doesn't move in lockstep everywhere. Regional atmospheric patterns can and do occasionally push in the opposite direction, even as the overall national and global trend continues warming. That regional variation matters because it points to something important about how climate trends actually work in practice. A 50-year warming trend isn't a smooth, uniform shift applied evenly across the entire map. It's the net result of countless individual years, each one shaped by its own specific combination of ocean temperatures, jet stream position, and atmospheric circulation patterns, averaged together over decades. Most of those individual years lean warmer than the ones that came before them, which is exactly what produces the long-term trend Climate Central documented. But any single year can still buck that trend for a specific region, particularly when a strong, well-understood atmospheric driver, like a rapidly developing shift in the ENSO cycle, pushes conditions in the opposite direction for that particular fall and winter. That's exactly the kind of regional override this fall's forecast is shaping up to include. To understand why 2026 could deliver an early freeze surprise to parts of the country, you have to start in the tropical Pacific Ocean, thousands of miles away from wherever you're watching this video, because that's where the atmospheric pattern steering this fall's weather actually originates. For most of the winter of 2025 into 2026, the United States was under the influence of a weak La Niña, the cold phase of a recurring ocean temperature cycle called the El Niño, Southern Oscillation, or ENSO, where sea surface temperatures in a specific stretch of the central and eastern equatorial Pacific run cooler than average. That La Niña pattern began dissolving through the spring of 2026, and forecasters have since been tracking a genuinely rapid reversal in ocean temperatures across that same stretch of the Pacific. One significant enough that meteorologists have started using the term Super El Niño to describe what's building for the back half of 2026, heading into winter. Rather than a slow, gradual transition, long-range ocean forecast models are showing values shifting quickly from the cold La Niña phase into a considerably warmer El Niño signature, with some forecasts suggesting this could become one of the more significant El Niño events of the past several years. That matters enormously for how the fall and winter play out across North America, because La Niña and El Niño don't just produce slightly different temperature outcomes. They tend to set up entirely different large-scale wind and pressure patterns across the northern hemisphere, and those patterns directly influence where cold air masses form, how they move, and how far south they're able to push. It's worth understanding just how large a role this single ocean cycle plays in shaping American weather more broadly, because it's easy to underestimate just how much influence a patch of ocean temperature thousands of miles from the nearest U.S. coastline can have. ENSO is widely considered the single most influential seasonal climate driver on the planet, capable of shifting the odds on temperature and continents simultaneously, sometimes for a year or more to stretch. Forecasters don't treat a transition between La Niña and El Niño as a minor technical detail. Its closest thing, seasonal forecasting, has to a reset button, one capable of flipping an entire winter's expected character from one extreme toward the other within the span of a single ENSO cycle. Winter 2025 into 2026 unfolded under a weak La Niña that, according to several forecasting groups, ultimately proved colder across parts of the northern U.S. than initial outlooks had suggested, partly due to its own bout of polar vortex disruption. Heading into a comparatively fast-developing El Niño for 2026 into 2027 represents a genuine flip in the driving mechanism behind the upcoming season, not simply more of the same pattern continuing forward. Here's the part of this story that actually explains the why behind an early freeze, and it starts several miles above the ground, in a layer of the atmosphere most people never think about, the stratosphere. Every winter, a massive, swirling pool of extremely cold air forms high above the North Pole, contained by a fast-moving band of stratospheric winds that circle the pole and act almost like a fence, keeping that frigid Arctic air locked in place up near the pole rather than letting it spill southward into the mid-latitudes where most of the U.S. population actually lives. Meteorologists call this entire system the polar vortex, and its behavior over the course of a given winter has an outsized influence on how cold weather actually reaches the continental United States. When that vortex is strong and tightly organized, the cold air mostly stays contained up near the Arctic, and winters across the U.S. tend to run comparatively mild. When the vortex weakens, wobbles, stretches, or in the most extreme cases, actually splits apart, that containment breaks down, and pockets of extremely cold Arctic air get released southward into the mid-latitudes, sometimes triggering the kind of sudden, sharp cold outbreaks that catch forecasters and the public off guard. The most dramatic version of that breakdown is called a sudden stratospheric warming event, or SSW, a genuinely wild atmospheric phenomenon where the temperature in the stratosphere above the pole can spike by tens of degrees in the span of just a few days, disrupting or even reversing the normal wind pattern that holds the polar vortex together. When an SSW event happens, it doesn't just affect the stratosphere in isolation. Over the following days and weeks, that disruption tends to work its way down into the jet stream closer to the surface, buckling it into a more wavy, unstable pattern that allows Arctic air to plunge much further south than it normally would, often triggering the kind of sudden, intense cold snaps that arrive well outside their typical seasonal window. Here's the critical connection for this fall's forecast. Research into the historical relationship between ENSO phase and stratospheric behavior consistently shows that El Niño winters carry a meaningfully higher chance of producing a sudden stratospheric warming event than La Niña winters do, with the effect particularly pronounced during December and January. That's a real, statistically documented pattern, not a loose correlation. With a rapidly strengthening El Niño now building for the back half of 2026, forecasters are already flagging an elevated risk of exactly this kind of polar vortex disruption as a key signal to watch heading into the coming winter. And the atmospheric conditions that eventually produce an SSW event and a resulting cold outbreak don't switch on overnight. The stratospheric setup that determines whether the vortex holds together or breaks down often begins taking shape well before the deepest part of winter arrives, which is part of why this fall's transition into an El Niño pattern is already being watched so closely, rather than something forecasters plan to revisit once winter officially begins. It's worth being clear about the timeline and the uncertainty involved here, because a sudden stratospheric warming event isn't something forecasters can pinpoint months in and advance the way they might track an approaching hurricane. These events typically become visible in forecast models only 1 to 3 weeks before they actually occur, once specific wave patterns in the atmosphere begin transferring enough energy upward into the stratosphere to disrupt the vortex's circulation. What forecasters can do, well in advance, is assess the broader seasonal odds, and a strengthening El Niño measurably shifts those odds toward a higher likelihood of at least one significant disruption event, occurring somewhere in the December through February window, even without being able to specify the exact date it might happen. That's precisely the kind of probabilistic signal driving this fall's early freeze conversation. Not a guarantee that a specific cold snap will arrive on a specific date, but a genuine, measurable increase in the odds that one will, at some point, arrive earlier and more abruptly than the recent warming trend would otherwise suggest. Long-range seasonal outlooks from multiple forecasting groups are already converging on a similar regional pattern for this fall, even though they don't agree on every detail. The Farmer's Almanac's Fall 2026 outlook describes a season of genuinely dramatic transitions, starting warm and relatively dry across much of the country in September, then shifting toward a colder, wetter pattern as autumn progresses, moving generally from north to south. Their forecast specifically singled out the north-central states and Great Lakes region is likely to experience the earliest and most persistent cold weather of the season, with the first winter-like conditions potentially arriving by mid-October and becoming more firmly established as November approaches. The Northwest is also forecast to trend colder and relatively dry through the season. On the other end of the spectrum, the Southeast is expected to hold onto warmth the longest, delaying that region's own first freeze well behind the pace being set further north. The Old Farmer's Almanac, a separate publication using its own long-range forecasting methodology, paints a broadly similar picture with some notable regional differences. Their Fall 2026 outlook describes a warm interior, wrapped by cooler conditions on both coasts, with the nation's interior running from the northern plains through the heartland and into the deep south, trending warmer than average through September and October, while both the eastern United States and the Pacific coast trend cooler than average across the same window. AccuWeather's long-range forecasting team, meanwhile, has pointed specifically to the building El Niño as a factor likely to delay the onset of widespread chilly weather for parts of the country, suggesting that summer-like warmth could linger longer than usual into the early weeks of fall in some regions, even as the broader system sets up conditions favorable for a sharper cold snap once it does arrive. That's not necessarily a contradiction. It's consistent with exactly the kind of pattern a strengthening El Niño tends to produce: a milder overall autumn punctuated by the elevated risk of a sudden, sharp disruption once the stratospheric conditions become favorable for it. Put those forecasts together, and a consistent regional story emerges. The upper Midwest, the Great Lakes, and the Northern Plains appear to carry the highest likelihood of an unusually early first freeze this year, potentially arriving by mid-October in some locations. The Southeast and much of the nation's interior look likely to hold onto warmth considerably longer, pushing their own first freeze dates closer to, or even later than, recent historical averages. There's a physical reason the upper Midwest and Great Lakes region consistently show up as the most likely entry point for early cold in outlooks like these, and it comes down to geography as much as atmospheric pattern. That stretch of the country sits closest to the typical southward track that disrupted wavy jet stream patterns take when a polar vortex event pushes Arctic air out of the high Arctic and into the mid-latitudes. Air masses moving south out of northern Canada tend to funnel most directly into the northern plains and Great Lakes before spreading further east and south, which is part of why this region so often serves as the first to feel the effects of any given vortex disruption, even in years when the cold air eventually reaches much further south as the pattern evolves. The Great Lakes themselves add an additional local wrinkle once that cold air does arrive. The lakes retain summer warmth well into autumn, and the temperature contrast between still relatively warm lake water and an incoming mass of Arctic air can enhance localized snowfall and temperature swings along the immediate lakeshore, a well-documented regional effect, separate from the larger-scale pattern driving the cold air south in the first place. It's worth pausing on why the specific date of the first freeze matters so much beyond simply signaling that sweater weather has arrived, because this single date carries real, measurable consequences across multiple parts of daily life. For farmers and home gardeners, the first freeze effectively marks the hard end of the growing season for the vast majority of crops and garden plants that aren't specifically cold, hardy. A freeze that arrives even a week or two earlier than a region's recent average can cut meaningfully into harvest windows for late-season crops, forcing farmers to accelerate harvest schedules or risk losing portions of a crop to frost damage. It's worth drawing a distinction here between a freeze and a frost, since the two terms get used interchangeably but describe different conditions. A freeze specifically refers to air temperatures dropping to 32 degrees or below, while frost can form and damage sensitive plants at slightly higher temperatures under the right combination of clear skies and calm, still air. Both matter for agriculture, but the first freeze date specifically tracks the harder threshold. The first freeze also plays a significant role in allergy season because it's typically what finally kills off the ragweed and other late-season pollen-producing plants responsible for a large share of fall allergy symptoms across much of the country. An early freeze effectively shortens that allergy season for affected regions, while a delayed freeze the more common outcome under the long-term warming trend, extends it, which is part of why allergists have been tracking freeze date data for reasons entirely separate from agriculture or general weather curiosity. And for utility companies and energy planners, the first freeze functions as an informal seasonal marker for the ramp-up in heating demand, helping inform everything from staffing decisions to natural gas and electricity demand forecasting heading into the winter season. A freeze arriving well ahead of typical dates, particularly if it's tied to the kind of sharp vortex-driven cold snap this fall's setup could potentially produce, can catch that seasonal ramp-up earlier and more abruptly than usual. A detail utilities in the upper Midwest and Great Lakes region are already factoring into early winter planning, given this year's specific outlook. There's a transportation and public safety dimension worth mentioning too, one that tends to get less attention than the agricultural angle, but matters just as much for millions of people. An early, sudden freeze catches road crews, transit agencies, and everyday drivers off guard in a way that a gradually arriving winter typically doesn't. Municipalities generally plan their salt and de-icing supply logistics, snowplow staffing schedules, and public winter weather, messaging around a region's typical first freeze timing. When that freeze arrives weeks ahead of schedule, driven by the kind of sudden vortex disruption event this fall's El Niño pattern carries an elevated risk of producing, it can arrive before some of that seasonal infrastructure is fully staged and ready, which is exactly the scenario transportation officials in early freeze-prone regions like the Great Lakes and Northern Plains are already watching for as this fall's outlook continues to take shape. Here's where this story ties together into something that sounds contradictory on the surface, but actually makes complete sense once you understand the mechanism driving it. El Niño winters, taken as a whole season, are generally associated with milder, warmer than average conditions across much of the northern United States. That's actually one of the most well-established and widely cited effects of the ENSO cycle, and it's part of why AccuWeather's own forecast suggested this fall's warmth could linger longer than usual in places before genuine cold sets in. So how can the same, overall milder, El Niño-influenced season also carry an elevated risk of an unusually early or unusually sharp freeze in specific regions? The answer comes back to the distinction between an overall seasonal average and a single sudden event layered on top of it. A strengthening El Niño raises the statistical odds of a sudden stratospheric warming event disrupting the polar vortex, particularly in December and January. And when one of those disruption events happens, it doesn't produce a mild, gradual cooling. It produces a sharp, sudden southward plunge of Arctic air that can arrive well outside its typical seasonal window and depart just as quickly once the pattern resets. That's precisely the mechanism capable of delivering a first freeze earlier than a region's recent average, even within a winter that, averaged out across its full 3 or 4 months, ultimately still lands on the milder side overall. In other words, this isn't really a story about the entire winter of 2026 into 2027 turning out unusually cold nationwide. Long-range seasonal outlooks, on balance, still lean toward a warmer than average season for large stretches of the country, given the strengthening El Niño pattern. This is a story about the risk of a specific, sudden disruption event, tied to a well-documented atmospheric mechanism that El Niño winters are statistically more prone to producing, capable of delivering an early, sharp freeze to specific regions, most likely the upper Midwest, Great Lakes, and Northern Plains, even as the broader seasonal trend continues pointing toward warmth almost everywhere else. As of late August 2026, ocean temperatures across the equatorial Pacific continue trending toward a strengthening El Niño pattern, with forecasters describing the transition as occurring more rapidly than a typical ENSO phase shift. Long-range models are already incorporating this developing El Niño signature into their outlooks for the rest of fall and into the early winter of 2026 into 2027, with particular attention on how it may interact with the polar vortex once the coldest part of the stratospheric winter cycle begins to take shape, typically starting to become more relevant heading into November and December. Regional seasonal outlooks from the Farmer's Almanac, the Old Farmer's Almanac, and AccuWeather's long-range forecasting team continue to broadly agree that the upper Midwest, Great Lakes, and Northern Plains carry the greatest likelihood of an early transition into winter-like conditions this year, with a possible arrival window as early as mid-October for the first true freeze in some of those locations. Meanwhile, much of the nation's interior and the southeast look likely to hold on to warmer conditions considerably longer, keeping their own first freeze dates closer to typical timing or later. As always with seasonal forecasting at this range, meteorologists caution that these outlooks carry genuine uncertainty, and the exact timing of any specific stratospheric disruption event remains difficult to pin down with precision more than a few weeks in advance. What makes this story worth paying attention to isn't really about circling a specific date on the calendar. It's about understanding that average and typical aren't the same thing as guaranteed, even when a 50-year trend has made a certain outcome feel almost inevitable. The overwhelming majority of American cities really have been seeing their first freeze arrive later and later, year after year, as the planet has warmed, and that broad trend isn't going anywhere. But climate trends operate on long timescales, averaged across decades, while any single year's weather is still governed by the specific atmospheric setup unfolding in real time, the ocean temperatures, the state of the polar vortex, and the countless smaller factors that can, in any given year, push a specific region against the grain of its own long-term trend. This fall's rapidly strengthening El Niño, and the elevated risk of a polar vortex disruption it carries heading into winter, is exactly that kind of real-time override. It doesn't erase the 50-year warming trend Climate Central documented. It sits on top of it as a genuine possibility that millions of people across the upper Midwest, Great Lakes, and Northern Plains could see their first hard freeze arrive earlier than it has in recent memory, driven by a specific, well-understood mechanism in the upper atmosphere rather than random chance. We'll keep tracking this story as the El Niño pattern continues to develop and as forecasters get a clearer read on the state of the polar vortex heading into the true heart of winter. If you want to know the moment the outlook sharpens for your specific region, make sure you're subscribed, because the same atmosphere that's been delivering warmer, later winters for 50 straight years just built the exact conditions capable of delivering the opposite, right on schedule for millions of people this fall.